Moving on to chapter 7, lesson 2, division properties of exponents. I don't think a lot of surprises in this lesson. Pretty similar to what we were doing yesterday with multiplication, but here we go. So consider our first example here, 2 to the 7th times, or divided by rather, 2 to the 4th. And if we expand this, it would be 2 to the 7th looks like this. 2 times 2 times 2 times 2 times 2. I should have used smaller exponents. 1, 2, 3, 4, 5, 6, 7, right? Means we have 2 as a factor 7 times. And it would be over 2 times 2 times 2 times 2. 2 to the 4th, right? And when you have factors that are the same in fractions like this, what can we do? We can cancel, right? A 2 over a 2 is just 1, so those 2's cancel. And then these 2's cancel, and these 2's cancel, and these 2's cancel. So what do we have left? We have 2 to the third left. So that example shows us what the rule is. The rule is that when we divide two powers with the same base, and we had a 2 to the 7th is a power and 2 to the 4th is a power, and they have the same base, we just have to subtract the exponents. Top exponent minus bottom exponent, okay? And so 2 to the 7th divided by 2 to the 4th just simplifies to 2 to the 3rd. All right, so now we get to work through a few examples. So g to the 3rd, h to the 5th over gh to the 2nd. So subtract the exponents for each base. It would be g to the 2nd, h to the 3rd. Okay, 3 minus 1 is 2, 5 minus 2 is 3. It's pretty simple, right? How about this guy? X to the 3rd over x squared would be x, and then y to the 4th over y is y to the 3rd. So x, y to the 3rd. And then let's get this guy worked out. K to the 7th over k to the 5th would be k to the 2nd over, or sorry, next is m to the 7th, and then that's it. The p's cancel out, right? Okay. All right. I don't know what else to say about that. That's pretty simple stuff. Now, let's consider how to do division or fractions when we have an exponent involved outside of the parentheses like this. All this means 3 fifths to the 4th power like this. All that means is we're going to use 3 fifths as 4 times as a factor, right? So it would look like this: 3 fifths times 3 fifths times 3 fifths times 3 fifths. And then we could simplify that. What is 3 times 3 times 3 times 3?
9.
Well, no, not in a number. It's 3 to the 4th over 5 to the 4th. And so it's just like when we had exponents of exponents yesterday in the multiplication lesson. We're going to multiply the exponents because the 3 here has an exponent of 1, right? So 3 to the 4th over 5 to the 4th is the way that would work out. So how about this next one? What would we end up with? X to the 3rd over y to the 3rd. All right, pretty simple stuff again. All right, so simplify things like this. Remember, we're just going to multiply the exponents. So this would end up being 3 to the 4th, p to the multiplying exponents, p to the 12th, over 7 to the 8th. Okay? How about this bottom one here? 5 to the 3rd, x to the 15th, y to the 3rd, 3 to the 3rd, z to the 9th. Okay? Whoops. All right, so now let's think about this. 3 to the 0 power.
Is 0. 3. Because there's no 3.
Yeah,
Just 0.
you can't multiply any sets.
Okay.
Nothing.
Actually, there was, I forgot. You're both wrong, both of you. by the
Wait,
way.
is this even possible?
Wouldn't it just be
Is this
3?
even possible?
Nope, hold on. There was, I forgot how they did it in the book. I wanted to write it out. I didn't write it down. Hold on, hold on.
So if there's no 0, I'm not leaving.
I love your speculations.
It equals.
I forgot how they did this in the book, but it was great. There we go. Okay. So we know this. If you have this, 3 to the 5th over 3 to the 5th, what's the rule about exponents? 3 to the, when you have an exponent over an exponent, what do? Subtract the exponents, right? So 3 to the 5th over 3 to the 5th is 3 to the 0. But what is 3 to the 5th over 3 to the 5th? If you take any number divided by itself, it's 1. Okay? So any number with an exponent of 0 other than 0, you can't put 0 as a base, but any number other than 0 with the exponent of 0 is 1. Okay? And so if you have this, x over y to the 0 power, what is it? It's just 1. What is 2/5 to the 0 power? 1. Okay? It's simple. You just have to kind of remember, anytime you see that 0 exponent, then you don't have to think about anything else. You don't have to work it out. It's just 1. Okay? All right. Now, let's think about this. X squared over x to the 5th. We haven't seen an example like this yet. Okay. So what would we want this to be? This would be x times x over x times x times x times x times x, right? So this would cancel, and so we would get 1 over x to the 3rd, right? 1 over x to the 3rd. But how else would we think about this if we were just using the rule that we used a minute ago? Yeah, that would be x. You take top number, top exponent minus bottom exponent, and what do you get? It would be x to the negative 3rd. Okay. Now both of these are right. X to the negative 3rd is the same thing as 1 over x to the 3rd.
So we could just put x to the negative 3rd?
You can just put x to the negative 3rd, or you can, it depends on what they're asking you to do. If they give you this and tell you to simplify it, then this is the way they want it to be written. Okay? Okay, so, and the way they were, it's, I didn't give you a lot of the mathy definitions, the way they word it, but here's the rule. When a base has a negative exponent, so our base here, x, has a negative exponent, move it to the denominator and make the exponent positive. Or, vice versa. What if I ended up with this? What if I ended up with 1 over x to the negative 2? Well, you have to move it, then it would be the same thing as x squared. Okay? If you end up with a negative exponent in the denominator, then it moves to the top and becomes positive. If you have a negative exponent in the numerator, the top, then it moves to the bottom and becomes positive. Huh? Well, they're going to give you stuff like this, and let's look at the next page here. Here's how it works out. Simplify it. So n to the negative 3rd is really 1 over n to the 3rd. Okay? Y to the negative 4th really is 1 over
x to the 4th,
x to the 4th, y to the 4th. Good. Okay, 1 over x squared, 1 over x to the negative 2 is move it to the top and make it positive. Okay, if the negative's on the bottom, move it to the top, make it positive. If it's on top, move it to the bottom and make it positive. So, I can't, my glasses aren't good enough to see those numbers. N to the negative fifth, p to the fourth over k to the negative 2. So, if it's negative, move it.
So it'd be k to the positive two.
K squared.
K squared,
And then
p to the fourth stays where it is because it's positive,
N to the fifth.
over n to the fifth. Okay? If it's negative, it needs to move so it becomes positive. Does that make sense? That's the basic takeaway there. That's what you need to do to remember. All right, holy smokes. Here's what we're moving towards. We're going to simplify these things. All right. So first of all, 10 and 2, neither one have exponents involved, so we can simplify that. So 10 over 2 is 1 over 5, right? 2/10 simplifies to 1/2. What is a squared over a? A where?
On the.
Oh, wait a minute. It's a to the negative third. I'm sorry.
Oh.
So a to the negative third, I can't see it from back here. Well, the a to the negative third needs to go where? Needs to go to the top and become positive. So you end up with an a squared a to the third on top. So what is that?
A.
A to the, now listen, here's the, think back to the very first thing we did with exponents on top and bottom. What do? You subtract, right? What is 2 minus negative 3?
Oh.
Five.
A to the fifth.
A to the fifth. Okay, and this is a b to the third over b to the negative 1. What's 3 minus negative 1?
B to
B to the fourth. And then you have c to the negative fifth over c to the negative fourth. What's negative 5 minus negative 4? Negative 1. And where would the negative 1 be? Well, no, the negative, because this number's bigger, the negative 1 would be up here on top, but we don't want a negative exponent, so where do we move it?
To the bottom is just
C, so it's just C on bottom. I know some of you are giving me the, oh my goodness, I'm confused look, and that's okay. I'm used to it by now. All right, Tessa,
How did you get like the 1 and the 5 at the beginning?
2 over 10. Just 2 over 10
Oh, yeah.
is 1 over 5. Since there are no exponents involved with the coefficients, then we can do that. If there are exponents involved with coefficients, you have to do the exponents first, right? You can't simplify unless they are the same coefficient. If it's like 4 squared over 4 to the third or something, then you can simplify it. But if it's like 2 squared over 10 to the fifth, then you can't simplify those until you have done the exponents. So 32 and 4, neither one have exponents, so we can simplify that. That's just 8 on top, okay? 8, a to the negative 8th over a to the third. So negative 8 minus 3, negative 11, but we don't want a negative exponent, so where does it go? A to the 11th on bottom, right? And then b to the third over b to the fifth. So 3 minus 5 is negative 2. We don't want a negative 2, so we leave it on bottom. So,
Wait, wouldn't it be on
That would be on
the
top
top?
of the
Yeah,
negative.
look, it's
Oh.
on the top.
but it's positive down here already.
No,
Yeah, but you're subtracting.
3
the
minus
five.
5. So the negative would be on the
If
bottom.
this was all we had,
Yeah.
if this is all we have, then you have b to the third minus b to the fifth. So, or 3 minus 5 would be just b to the negative 2, right? That's all that's left.
And that'd be on the
I don't want that. That's on top. So I have to put it like this. It's 1 over b to b squared. B squared has to be on bottom. All right. Negative 4 minus negative 2 is negative 2. That's on top. So I need to put c squared on bottom, right? All right. A 11, B squared, C squared, yep, all right. And then A to the fifth, B to the fourth, 5C. We don't need, by the way, this one can go away right here. We don't need that one, right? Because one is a factor is irrelevant. All right, so there we go.
Do we need to do all the